Okay. So K-means clustering is an unsupervised learning technique which groups or clusters unlabeled data points into different clusters based on distance. So K-means cluster is an unsupervised learning algorithm which uses the distance mechanism to calculate the distance, and based on the distance, it will group the observations into clusters. Now, the primary difference between, you might say KNN also does the same thing. The primary difference between KNN and K-means is KNN requires a dependent variable. KNN requires a dependent variable. Why? Whereas K-means works on both labeled and unlabeled data. On both data with dependent variable, data without dependent variable. So the primary difference between KNN and K-means is this. Both of them are Euclidean distance, based on distance only. KNN is also distance-based methodology. K-means also a distance-based methodology. KNN assigns the neighbors based on the distance. Here also based on the distance between the centroid and the labeled point, unlabeled point, it will allocate the cluster. Now, K-means is an iterative algorithm. K-means is an iterative algorithm where each cluster is associated with a centroid Centroid means the midpoint. And aim of the algorithm is to minimize the sum of square of distance between the observations and centroid. So this also uses the distance measure, and based on the distance, it will allocate the data to the clusters. It's an iterative algorithm because it performs many iterations till the point the clusters cannot be realigned. As long as there is a change in the cluster allocation, it will run. The moment it finds that clusters cannot be reallocated or realigned, then it will stop. So this is the theoretical background of K-means cluster. Okay. Now the K here is number of clusters. The K here is number of clusters. Now we don't have the formula to decide the exact number of clusters. So we go with a random assignment. Then we plot the error on the scree plot or elbow plot, and then we'll find the correct number of clusters. Okay. So K means the number of clusters. K means the number of clusters. Initially, we have to come up with a random number of clusters. Then once we build the model, we will finalize our clusters by plotting a elbow plot or a scree plot, the point at which there is a bend. That will be your number of clusters. Okay. Now let us do this calculation mathematically to understand the algorithm. So for this data, we will be randomly assuming K is equal to 3. Let us assume the K value is equal to 3. I am just randomly taking K is equal to 3. Now, randomly it identifies 3 centroids. In the first iteration, from the existing set of observations, it randomly identifies 3 centroids. In the first iteration, it randomly identifies 3 centroids from the existing data. It just randomly takes 3 centroids. Take, for example, in our case, it has taken the data as 210 as one centroid. It has taken 58 as the second centroid and 12 as the third centroid. It randomly takes 3 centroids from the given data points. From the given data points, it randomly identifies 3 centroids. Now we have to calculate the distance from centroid 1. Centroid 1 is 210. 2, 10 is your centroid 1, which is randomly identified. Then we have to calculate the distance from centroid 2, which is 5, 8. 5, 8, the centroid 2, and distance from centroid 3, which is 1, 2. So you have to calculate the distance between these centroids. The distance between these centroids. These initial centroids in the first iteration are randomly selected by the algorithm. And it uses Euclidean distance. We will use Euclidean distance here. What is the formula for Euclidean distance? Square root of x2 minus x1 whole square plus y2 minus y1 whole square, close bracket. So we will use Euclidean distance as a metric for calculating the distance, Euclidean distance, right? So let us calculate from the first is equal to SQRT open bracket 2. X2 is 2. We have to fix it by pressing F4 minus same 2 to the power of 2 plus open bracket 10 is our y2, again fix it, minus 10 to the power of 2 close bracket. We'll get it as 0. Now if I drag the formula down, I'll get the centroids as these new centroids, and I'll decrease the decimal to 2 points, and I will center them. And I will also make it as, so this is the formula. This is the formula for the first distance between the first centroid and other observations. Square root of 2 and 10 are our x2 and y2. So we have to fix them. And the same value is the first observation. So we are taking it as the free cell, because the free cell has to change, right? As you drag the formula down, the cell value has to change. That is what we are doing here. So square root of 2 minus 2 whole square plus 10 minus 10 whole square. For the next row, 2 minus 2 whole square plus 5 minus 10 whole square. Right? Got it, all of you? Now, same thing we will implement here. Is equal to SQRT. Here, what is the centroid? 5. That centroid needs to be fixed by pressing F4. Minus 2 to the power of 2 plus open bracket. Centroid will be 8. Fix it by pressing F4 or Fn minus F4 to the power of 2 close bracket. So we'll get the distance, and if you if you drag the formula till here, you'll get the distance. This will be 0. Again, we will make it to 2 decimal. We will all brackets, all borders, and center. Same thing here is equal to SQRT open 2 brackets. This centroid is 1. Fix it by pressing F4 minus 2 to the power of 2 plus open bracket 2 is the centroid, press F4 minus 10 to the power of 2 close bracket. So you got this as the distance, and anyway this will be 0. So we will reduce it to 2 decimal, all borders, center. So this is how we calculate the distance between the centroids and the observations. So Euclidean distance. Got it, all of you? Now the cluster assignment. Cluster assignment will be based on the minimum distance. What is the minimum among these three? Cluster 1. C1 is the minimum. What is the minimum among these three? C3. Cluster 3 is the minimum. What is the minimum among these three? 5. C2 is the low. Minimum of these three, C2. Because 0 is the lowest. Minimum of these three, again C2. Minimum of these three, again C2. This is C3. This is again C2. These are the cluster assignments done based on the distance, least distance among the three. Least distance among the three. Got it, all of you? Now I'll copy the data again, only the data. So I'll paste it here. Remove the color codes, clear formats. Okay. Now the cluster 1 C1 remains the same, right? C1, there is only one observation C1, and what is its values? 2, 10. 2, 10 is for C1, right? Now we have C2 multiple observations. 1, 2, 3, 4, and 5. So 1 is 4 and 5. Now, if you see the average below, you can see the average here. 6. 6 is the average for C2. The new centroid for C2 is 6, comma. You have to calculate the other one also. So these are all C2s. Shift control and one more. Again, the average is 6. So the centroid changed for C2. C2 cluster C2 centroid has changed. Similarly, C3, we have two observations, 1 and 1. So the average is 1.5. So this is C2 cluster 2. Now distance from C3, C3 also 1.5, comma, and this is C3 and this is C3. Again 3.5. The next centroid is 3.5. So we have centroids changing for C3 and C2. C1 remains same. C1 remains same. The average of all the cluster values, right? So these are the new centroids. We will calculate the distance again. SQRT, open two brackets, fix it F4 minus the same value to the power of 2 plus open bracket 10, fix it minus 10 to the power of 2, close bracket. And we drag the formula till this point and we will make it to decimal. Here the centroid is 6. The new centroid is 6 is equal to SQRT, open two brackets, 6 minus this to the power of 2 plus open bracket 6 minus 10 to the power of 2, close bracket. 6 is the new centroid. If you drag the formula down, you will get all as 6 minus, right? This is also 6 minus the cell value. 6 and 6 are the fixed centroids, right? So again, I will reduce the decimal to 2. And for this is equal to SQRT, open two brackets, 1.5 minus 2 to the power of 2 plus open bracket 3.5 minus 10 to the power of 2. The new centroids. And then okay, now I'll make this as 2 decimal. All borders and center it down. So new centroids for C2 and C3. C1 remained the same, 6 and 6. This is averages. And then we will do the cluster assignment. The new cluster assignment would be, this is C1, this is C3. Oh, we have all C3. This is C2. This is C2. This is C2. This is C2. This is C3. This is C1. This is iteration 2. All right, all of you got this? So we had a cluster change. The last cluster initially was C2, now it became C1. There was a change in the cluster alignment. The last cluster was C2 in the previous iteration. Here, the last observation now is clustered as C1. So we have a change. That means we need to recalculate the again distance. In the next iterations, if they all stay the same, we'll stop there. Otherwise, we have to continue till the point where we have a change. So I'll copy these data points, Control C, Control V. So dist C1 will change. So we have two C1s now, the first one and the last one. So the average is 3, comma, the first one and the last one, which is 9.5. So the centroid for the cluster 1 has changed. This for C2. C2, any changes are there? Yes, because C2, one C2 converted into what you call C3. So these are your C2s only. So what is the average? 5.25. So 5.25, and this would be C2 should be 5.25. No, I think we have made a mistake here. These are the C2s, right? The 6.5. 6.5, comma, 5. This is would be 5.25. 5.25. And cluster 3 remains same. There was no change in the cluster 3. So we'll take it as it is. So there was a change, only 2 clusters. Cluster 1, one observation moved from C2 to C1. So the distance for C1 and C2s will change. Now is equal to SQRT double two brackets 3 minus to the power of 2 plus open bracket 9.5 minus this to the power of 2 close bracket, and you drag the formula till here. 2 decimals. Similarity is equal to SQRT open 2 brackets 6.5 minus this to the power of 2 plus open bracket 5.25 minus this to the power of 2 close bracket. We'll get the new distances, minimize them to 2 decimal. Then this one, last one is equal to SQRT open 2 brackets 1.5 minus 2 to the power of 2 plus open bracket 3.5 minus 10 to the power of 2 close bracket. This also we will reduce it to 2 decimals. So these 3, we make it this, and then we will center them. Then cluster assignment. This will be C1, this will be C3, this will be C2, this will be C1. Again, we have a change. This will be C2, this will be C2, this will be C3, this will be C1. The new cluster assignment, minimum of the distances. Minimum of the distances. This is your iteration 3. So we have again a change. So we have to redo the calculation again. So again, we have a change. One cluster 2 observation became cluster 1. So I'll copy the data, Control C. Now we have cluster 1s, 1, 2, 3. So the average is 3.67, comma 1, 2, 3. The average is 9. So cluster 1, 3.67 and 9. Distance from cluster 2. Again, cluster 2, we have a change. 1 cluster 2, 2, 3. So the average is 7. And then this one, 4.33. Distance from cluster 3 remains same because there is no change in the cluster allocation, 1.5 and 3.5. There is no change in cluster 3. So is equal to SQRT, open two brackets, 3.67 minus 2 to the power of 2 plus open bracket 9 minus 10 to the power of 2 close bracket. And the formula down, 2 decimal is equal to SQRT, open two brackets, 7 minus 2 to the power of 2 plus 4.33 minus to the power of 2 close bracket. And this would be is equal to SQRT, open two brackets, 1.5 minus 2 to the power of 2 plus open bracket 3.5 minus 10 to the power of close bracket. Cluster assign. Cluster assign. This would be C1. This would be C3. This would be C2. This would be C1. This would be C2, C2, C3, and C1. So there is no change in the cluster alignments. So we will stop at here. So these are the final cluster allocations. Okay, all of you got the K-means clustering. This is the methodology for K-means clustering. Got it? So there is no cluster change. So this is our final cluster alignment. Got it, all of you? Now this is a centroid based mechanism where we are using the centroids as the distance measure to do the clustering. There is one more method of clustering called hierarchical clustering, or also called as agglomerative clustering. There is one more type of clustering called hierarchical clustering. Hierarchical clustering, also called as agglomerative clustering. It uses the same distance methodology, distance-based clustering. The output is a dendrogram. You will get a dendrogram as a output. So agglomerative clustering or hierarchical clustering is a clustering again based on distance-based methods only. But in here, the grouping of data is slightly different. So we will get a slightly different type of output. We call it as cluster dendrograms. We will get it as a dendrogram. Hierarchical clustering, or also called as agglomerative clustering. Hierarchical clustering or agglomerative clustering. Now, in this clustering, there are different methods called single linkage method, complete linkage method. Hierarchical clustering methods, we have different methods. Single method, what you call complete method. Now, this is very important. They'll ask in interviews also, what is the difference between a single method and a complete method? Single linkage method uses this minimum distance between two clusters. Single method uses the smallest distance between two clusters. The complete method uses the largest distance between two methods. Average will calculate the average of the values, and then distance between the average and the cluster is taken into consideration. So these are the three methods: single linkage, what we call it as complete, and average. The three methods of clustering methods in hierarchical. Single is minimum distance, complete is maximum distance between 2 points, and average is you will take the average of the 2 points. So hierarchical clustering or agglomerative clustering is also distance-based method, but the way it does is the minimum distance. In K-means, we are taking the minimum distance. In K-means, we are taking the minimum distance. In hierarchical, we have an option. We can take the minimum distance, which is called the single linkage method. We can take the maximum distance between two clusters. We call it as complete linkage method. Or we can take the average distance, which is the average linking method. So how you link the clusters is very important here. That is what these methods are: single versus complete versus average. Okay. Now let us say we have some data points, P1, P2, P3, P4, P6. And then we have X and we have Y. X is 0.40, 0.53. This is 0.22. This is 0.38. This is 0.35. This is 0.32. This is 0.26. This is 0.19. This is 0.08. This is 0.41. This is 0.45. This is 0.30. So we have these data points with X and Y coordinates given to us. These are the data points. But now we need to calculate the distance, right? Euclidean distance we have to calculate for each of the data points. We will randomly take some value and we'll calculate the Euclidean distance, right? We'll take some random value and we'll calculate the Euclidean distance of all the observations. Okay. Let us say we got the distance matrix as this. Okay. Now, let us say we want to calculate distance between different points, point 1 to point 2, point 1 to point 3, point 1 to point 4. You can calculate different distances, right? So take, for example, I'm calculating distance between point 1 and point 2. Okay, what is the value of point 1 and point 2? Point 1 and point 2 is what? So 0.40 and 0.22 for x, 0.53 and 0.38 for y. Okay, is equal to SQRT, open two brackets, 0.4 minus 0.2 to the power of 2 plus 0.53 minus 0.38 to the power of 2, close bracket. So we got 0.2313. So we will create a distance matrix. Okay, the distance matrix will be created, Euclidean distance matrix. Okay. Okay, in distance matrix, generally, you know the matrix format of distance, right? So we will only have the P1, P2, P1, P2, P3, P4, P5, 6. And similarly, we will also have the same distances based as transpose, right? So this has to be down. So between P1 to P1 is 0, right? Between P1 to P2, we have calculated it as 0.23. Let us round it off to 2 decimals. This is 0.23. Right? Now we have to calculate distance between P2 and P3. P2 and P3. P2 is how much? 0.22. P3 is 0.35. And this is 0.38. This is 0.32. So we got 0.14 between P2 and P3. Right, P2 and P3. This is the point, right? 0.14. Got it? Now, if you want to calculate between P1 and P3, P1 is how much? 0.4. P3 is how much? 0.35. Similarly, 0.53 and P3 is 0.32, right? What is the distance? You got 0.22. Here you will pay 0.22. You're getting the distance, right? Distance between each of the points. P3 to P2 to P2 will be 0. P3 to P3 will be 0. P4 to P4 will be 0. P5 to P5 will be 0. And P6 to P6 will be 0. Right? And then we'll populate the rest of the distances by calculating the value. So P1 to P4. P4 is how much? 0.26 and 0.19. So you got 0.37. 0.37 as the value. P1 to P5. 0.08, 0.41, you got 0.34. Similarly, P1 to P6, 0.45 and 0.30. We got 0.24. 0.24. P1 to P6. Similarly, P2 to P4. P2 is how much? 0.22, 0.38. So P2 to P4, P4 is how much? 0.26 and 0.19. So we got P2 to P4 as 0.19. P2 to P5 is 0.08, 0.41. We got 0.14. Right. This would be 0.45 and 0.41. So we got 0.3, right? Sorry. 0.24. Okay. So you are calculating the distance between points. So P3 to P2, we already calculated it as 0.2. This will be the same value. So we don't need to calculate again. So, but we have to calculate P3 to P4. P3 is how much? 0.35, 0.32. So P32, we have to calculate P4, 0.26 and 0.19. So it is 0.16. Similarly, between P5, 0.08 and 0.41. This will be 0.28. Similarly, this would be 0.45. This will be 0.30. This will be 0.10. Then this would be 0. We'll calculate this also from P5, right? What is P5? 0.08 and 0.41. So P5. Oh, this is P5 to P. This is 0, right? No. This is 0, right? P4 to 0. So we have to calculate P4 to P5, right? So 0.26 and 0.19. So P4 to P5, 0.08 and 0.41. This would be 0.28. This would be then 0.45. This would be 0.30, 0.22. The last one is between P6, right? P5 is 0.08. 0.41, same, right? So we got 0.39. So this is the distance matrix which we have calculated. This is the distance matrix which we have calculated from all points to all points. Got it, all of you? Agglomerative clustering data points. Now, identify the two clusters with the shortest distance. Identify the clusters with the shortest distance. So if I plot this as a scatter plot, how will I look like? How would it look like? The whole matrix, and right. So, which are the two clusters that are shortest to one another? I think P3 and P6. P3 and P6 are the closest points. I think these are the two closest points, right? P3 and P6. This is the closest point. Not getting clusters properly. Okay. So this is the closest value, right? The minimum. We are using single linkage. Single linkage. Right? So the minimum is P3 and P6. Min is P3, comma P6. Right? Minimum is P3, comma P6. So that means they'll go in one cluster. P3 and P6 will go in one cluster.
Sir, this 1 point what does this mean?
0.1 is the distance between two cluster points.
Smallest
Smallest distance is between P3 and P6. Right? This is your P6. This is your P3.
and here we have to define the K.
Here there is no K. Where is the K? This is hierarchical clustering. There is no K here. So P3, P6 will be the new distance. These will be combined as one cluster. Right? Now the distance matrix will change. The distance matrix will change. So what happens is P1, P2, and now we have P3, comma P6 as 1 point, and then P4 and P5, right? And the same things will happen. Control C, you can transpose them here. This is the values. Okay. Now we have 0, 0.23. P3, P6 will be 0.22. Then P4 would be 0.37. This would be 0.34, right? And the other values are same. 0.14, 0.19, control 6. Here, we'll paste them here. This is 0. P2 to P2 is 0. This will be 0. P4 to P4 will be 0. P5 to P5 will be 0. Right? And then we will paste these values. Once control C and control V. And we have only one value here, which is 0.28. This is the new distance matrix which is created after merging P3 and P6 into one cluster. Now we have to calculate the distances again. Now this time we will calculate the distance between P3, P6 to P1. Distance between P3, P6 and P1, right? I'll copy paste these formulas, control C. I'll paste them here, paste special as formulas and number formatting, okay? Now we need to calculate the distance. P3, P6, how much is P3? 0.22. and 0.24, right? 0.22 and 0.24. What is P1? Sorry, 0.22 and 0.24, right? This is P1 and P6, right? Or let me do it this way. This is P1, this is P6. What is P1? 0.22, right? 0.22 is P1 from original matrix. P1 is how much? 0.4, 0.4, right? From the original matrix, P1 is 0.4. Min of these two. So this is P3, sorry. So I get confused. P3 and P6, right? Here we need to find min of P3, comma P1 and P6, comma P1. We have to find the min of P6, comma P1 and this thing. So what is the P1 original matrix? P1 is 0.40, right? Sorry, distance matrix, right? So P1 is how much? P3 to P1, 0.22. P3 to P1 is 0.22. P1 to P6, 0.24, right? Sorry, 0.24. What is the minimum distance? 0.22, right? The lowest distance is what? 0.22, right?
From this matrix,
Huh.
0.14.
This matrix P2 to P5. No, we have to create another distance matrix. We have to create another distance matrix 0.24, 0.22, 0.37, 0.34. After that, we need to find the minimum of the distances, right? So the minimum of the distances matrix would be this. P2 to P5 is the lowest. This is the lowest, right? P2 to P5 is the lowest. P2 to P5 is the lowest. So, so this is the minimum. So min is P2, comma P5. We will ignore that 0.14 because this already coupled into one, right? So we will ignore that. So minimum distance is P2 to P5. Now we will create a new matrix, right? Where P1, P2, comma P5 and P2, comma P5, P3, comma P6, and then P4. We will take these values, Control C, insert one. Okay, this is the new matrix. we'll get 0. This will be 0. This will be 0. This will be 0. Okay. And then P2, P5 is how much? 0.24 or 0.23, sorry, 0.23. Then P3, P6 is 0.22 and P4 is 0.37. This is how much? 0.14. This is 0.19. This is 0.16. This is 0.16. I'll take from these values only. Which one? 0.24, na? 23, na? This is the value. P2, P5 is 0.24, right? 0.23. Same values, na, we are taking. Now, what is the lowest of all these things? This is the lowest thing, right? This is the lowest thing. This is the lowest thing. So we are combining P2, P5, P3, 6 into 1. Okay, in the next matrix, P1, here we have all the things. P2, comma, P3, comma, sorry, P2, 5, P5, P5, comma, P3, comma, P6 as 1, and then P4 as 1. Same you transpose as the headers. This is 0, this is 0, this is 0. What are left out? P3, 5, 6 is 0.22, 2.22. This would be 0.37. This would be 0.14. Which one is? Oh, this one, huh? Okay. Yeah. This would be what? P4 2, P2 3, P6 would be 0.14. So this is the lowest value. See here, this would be 3 and 6. First cluster is 3 and 6, right? The first cluster is 3 and 6. The This is 3. The first cluster will be 3 and 6, right? We have combined 3 and 6 as the first cluster. What is the next cluster? Next cluster is this is 2. This is 2, 5. And these two are also connected by one cluster. Two, 5 has one cluster, right? And on top of this, we have one more thing called these all should be in same line. This is cluster 6. Sorry, cluster 4, right? Cluster 4. Three, 6, 2, 5, 4. And the last one would be the individual cluster. This is the clustered one. Finally, we will have only cluster 1 as the separate one, right? The last distance matrix would be, I'll put the last distance matrix. The last distance matrix would be P1 and P2, P3, P6. We'll add P4 to this, comma P4. Then transpose, this would be 0, this would be 0, this would be, what is the final value? Between P1 and all, 0.22, or sorry, 23. Right? This is the final matrix. And this is the dendrogram. Cluster 3 to 6, 1, then 2 to 5, 1, then 4 as a 1, and then 1 as the final cluster. Got it, all of you? This is hierarchical clustering based on clustered dendrogram. So this is the output. You will get this as the final output. The clustered dendrogram, you will get this as final output. Got it? Now you can